This is how to solve question 167 from chapter 11. The full question will be in the description. For now, we will determine the heat transfer effectiveness and the outlet temperature of the oil. So let's get right to the givens. So we have the CPC is 1007 joules per kilogram Kelvin. And CPH is 2047 joules per kilogram Kelvin. And mass of C is 0.21. Mass flow rate of C is 0.21 kilograms per second. Of H is 0.026 kilograms per second. TH is 75 degrees Celsius. TCN is 30 degrees Celsius. U is 53. And the surface area is just 1 meter squared. So what we need to find is emissivity and TH out. Now for reference, the C is for air and the H is for oil. So gotta find those two things. Let's start off with finding CH. CH is MACPH, and that is 0.26 times 2047, and that equals 53.12. 3 twos. Next we find CC, and that's, well, these are dots, right? Oops, boop, boop, because it's flow rate. So C, so then use the CPC, and that equals 0.21 times 107. Well, not 107, but 211.47. Next, we find which of these two is the smaller value, and CH is the smaller value, so this also equals C minimum. So then C equals C minimum. Oh, this one's C maximum. So this is C minimum over C max. And that equals, just plugging these into here, is 0.25166. Next, we find Q max. That equals C min times THN, the temperature of the oil in, minus the temperature of the air in, and you get 0.22 times 75 minus 30, and plugging that in gives you 2394.9. Next, we determine this. plug that in. U was given before in the problem statement, 53. So was the surface area, and C min we calculated to be 53.22. So this equals 0.9958. Now we can calculate the emissivity, which is 1 minus e to the power of NTU times 0.2 to the power of 0.22 divided by C, which we calculated, times e to the power of negative C NTU 0.78. Minus 1. Okay, so this C becomes 0.25166, and TU becomes 0.9958, 0.9958. Oops. The C again is 0.25166, and let's write negative here so we remember that that's negative. We plug that in and we get 0.5855 as our first answer. Next we need to find TH out. So we calculate the actual heat transfer. And we get 0.5855 times 2394.9, and that equals 1402.21. Now we can find the temperature of the oil coming out. And that equals the temperature of the oil coming in minus Q over CH, which is for the oil. And that equals 75 minus 1402.21 divided by 53.222. Plug that in and we get 48.65 degrees Celsius. And that's how you do that problem.